Good morning, class. So today we're looking at rational numbers. Now we've dealt with rational numbers before. Okay? So the introduction we are given here is that the integers, which is denoted by that Z symbol, okay, can be further extended by adding fractions. Okay, so we looked at integers in the previous topic, not so? So now we're going to add fractions to it. So if fractions is added to integers, you set up integers, then we get what we call rational numbers. And the rational numbers is denoted with the letter Q. Can you see that? So rational numbers Q is equal to integers plus fractions. You guys got that? Which page are we on? Page 59. Page 60. 59, page 60. Okay, so at this point you guys have written down all of this, no? Is that correct till here? Yes. So the definition of rational numbers: a rational number is an integer over an integer. You must write this. This is very important. Okay. A rational number is an integer over an integer. There's one value that integer cannot be equal to in the denominator. The denominator can never be equal to 0. Not so. You can't have a denominator of 0. Otherwise the sum will be a problem or non-real. No solution. Not so? You did that in primary school? No. If you look at 6, you got 6 apples, you divide by 3 people. How many apples does each person get? 2. You got 6 apples and you divide by 2 people. How much apples does each one get? 3. You got 6 apples divided by 6 people. Each one gets 1. You got 6 apples divided by 12 people. Each one gets half. You got 6 apples divided by 1 person. 6. You got 6 apples divided by no people. How much? The question is, how much apples does each person get? There's no people. So you can't, there we go, you can't divide those apples divided by no people. It will be a no solution sum. Can you see that, people? But if you have no apples divided by 6 people, listen now, no apples divided by 6 people. How much apples does each person get? 0 apple. I said, listen. You don't. What's wrong with you? No apples divided by 6 people. How much apples does each person get? No apples. However, if you got 6 apples divided by no people, then it's no solution. Not O, it's a 0, no? It's not a O, it's a naught, it's a 0. No, it's not the same difference. It's not the same, no. 0 and O is not the same. Okay, so make a note there, no? So later on we will go into where we look at the denominators can't be 0 and stuff like that. Okay, but there's many sums of that still to come. But for now we're keeping it simple, no? You guys are still babies, no? Yes, still babies in maths. We're all still babies, no? Even if you think you know a lot, I'm sure that there's people that knows much more than us, no? So examples of rational numbers, we got 3. 3 can be written as 3 over 1. So any number that can be written as a fraction, an integer over an integer, is called a rational number. Not so. So you don't have to list all of these down, but this is examples of rational numbers now. Okay. 3 can be written as 3 over 1. A half. So half. 1.5 can be written as 3 over 2. Negative 5 can be written as negative 5 over 1. 0 over 1 is 0. 0,25 can be written as 1 over 4. Negative 22 over 9. All of those are rational numbers. The square root of 9 over 16 is 3 over 4, and so on. Okay, you all okay with that, people? Right. Simplification of fractions. People, we've dealt with fractions in term 1. We spent a lot of time on fractions. No? We did BODMAS fractions, we did fractions from that red book, all of those things. Not so, all of that's going to come into play now. Okay. 12 over 18 is equal to 2 over 3. Is obtained by dividing the numerator and the denominator by the highest common factor, namely 6. You all agree with that? 6 can go into both. However, if you had said you got 12 over 18, 2 goes into here 6 times, 2 goes into here 9 times, it's going to give you 6 over 9. But 3 goes into here twice, 3 goes into here thrice, it's going to give you 2/3. Not so? But you must always remember that you must write the sum in the simplest form. Not so? Right. But if you see 6 is the highest common factor there, which means to say 6 can be divided into 12 and 18, then we tend to divide it first one or from the first time. From the offset we divided by 6. Okay. Here we got more examples here. We are told that 20 over 24, what is the highest common factor there? The highest common factor is 4. 4 goes into 25 times, 4 goes into 24 6 times. So it's 5 over 6. You all okay with that? Let's look at the next one. 25 over 45. 5 goes into both. 5 goes into 25 5 times. 5 goes into 45 9 times. So it's 5 over 9. 1.3 is example there. We are told you got 9 over 18. 9 goes into 9 once, 9 goes into 18 twice. It gives you 1 over 9. The highest common factor is 9. You guys understand? Right. So if you're looking at the sum here, I actually meant to have hidden that solution. I realize now I should have. Then we can discuss what's happening here. Okay. So it says, determine the value of x in. So write the sum down. This is example on page 59. Determine the value of x in. Okay, so what do you think the x value is in the first sum? 6. Who said something other than 6? Okay, how do we get 6? 3 times 2. Okay, so we say, okay, from the known, from 8 to 16, I multiply by 2. So what I do to the denominator, I must do to the numerator. 2 times by 2, excuse me, 3 times 2 is 6. Therefore x equals 6. Not so? Yes, sir. Right, do the number 2.2. 2.2. Yeah, just clean that table, no? Yes, clean up. Right? Right, so what's x in the next one? 5. You all agree with that? Yes, sir. 5. How do you get 5? How do we get from 18 to 3? You divide by 6. Divided by 6. So therefore, 30 divided by 6 is 5. Nice. You guys got it? No? Good. I'm looking at exercise on page 60. Not exercise, the examples. That's an exercise here. No examples. You just want me to be wrong. What's wrong with you guys? That's it, examples. Doesn't be like it with me. Right. 2.3. They got 2.3 twice. It's different sums, so you just do it. So marking your test. Let's see. Or is this you? Now why did they give me another name for you now? Sorry? Good. Jesus, there goes your chocolate. You didn't study. Didn't study already, no? What's negative divided by negative? Should give him more one money. You're just somebody's child. No? Did you come with 0? You can't make up your own sum. Right, you guys ready? Right. So what is your x value? Negative? Yes, absolutely correct. How do we get that? So we know that this is going to be negative, so here must be a negative here. Not so? And 1 times 2 is 2, so I'll multiply that by 2. Not so? So that's going to give you a negative 4. Huh? Why can't I say negative on top and negative? Okay. You all agree with that? Right, yes?
How do you know if the answer must be negative or positive?
Okay, so say you got negative half, and you got 2, and you didn't put a negative here. So 2 goes into 2 once, 2 goes into 4 twice. Is half the same as minus half? No. So they must be. You understand? Right? 2.3. Take 2. So the second one. What's that answer? Yes? You fuse. Nice. Nice. Yes. It's my goal on that side.
I don't know, maybe it's my eyesight.
Your eyes.
2.3 and then 2.3 and then 2.3.
My God sounded definitely wrong with your arms. Definitely. But anyway, and something wrong with your ears. I said that earlier on in the reading.
Oh.
They have written 2.3 twice, but it's different sounds. Did I not say that? It just shows how much you listen to what I'm saying. It's very little. But it's fine, don't worry. So since you're talking, what is that answer? Not talking anymore, okay. It's fine. Try. What's your answer?
I didn't.
You didn't do it.
Yeah, I went right to 2.4.
Now what's your answer to 2.4?
X equals negative 30.
Nice, I like it. It's nice, no? You got negative 30 here, people. Remember that is over 1. Not O. You see, they're the same like the other guy now. The O is not the same like a 1. Okay? That is naturally over 1. So how do I get from 1 to negative 2? You multiply it by negative 2, not so? And 15 times negative 2 is negative 30, which makes? Khadija, correct. Yes? 2.4 is negative 30. 2.3, we're getting now. Times 2 plus 1 now. Who has an answer to the one we skipped? Yes, Layla, yes. Positive 30. No. Positive 30, how do you get 30? You're right, you're absolutely correct. Positive 30 is correct. How? How do you get that, Michael? Yes. You say yes. Nice. See, when you can simplify it first. So 4 goes into here twice, 4 goes into here thrice. So negative 2 over 3. Oops. So that is negative 2 over 3. Then you see, how do you get from negative 2 to 20? Multiply it by 10. So you multiply that also by 10. Smart, ne? See, look at it this way. If you got 2 over 4, we know that is half, ne? That's the same as, say, 2, say, (17 over x). Now 2 over 4 is a half. So this must, this side of the fraction must also be half of the equal side. So 17 over what is half? 17 over 34. So x is 34 here, not so. But there's not a direct calculation here. There is actually, but at this level, there's no direct calculation. Not so. So what we do is they simplify this first. 2 going into once, 2 going into 4 twice. So I get a half. Not so. So you go 1 times what is 17? 17. 2 times 17 is 34. Does it make now sense?
Yes, sir.
Okay, and that is on the same account. Let's explain it here now. The same basis. We got negative 8 over 12 is equal to negative 20 over x. We tell ourselves, okay, 4 goes into 8 twice, 4 goes into 12 thrice. So in other words, it's negative 2 over 3. Not so?
Yes.
So how do I get from negative 2 to 20? Times by 10. So 3 times 10 is 30. Now you start to balance around, okay. That you guys understand? Any confusion? Right. Whoops. Sorry. Right, there's the next two. Oh. Okay.
Your attention, please. Mabelente Faku, can you please report to the office? Mabelente Faku, please report to the office. And the clothing shop is open now for any purchases. please make sure you make all your purchases what you need. Thank you.
Alright. Is the next two? Let's do this quickly before we break for interval. Right, so let's just do this quickly. Something else I want to show you before we leave. Alright, so how do I get from A to 5A? Times by 5. So I'll multiply this also by 5. Not so. X equal to? Yes? No. When you're working with the ratios or fraction, you must multiply with it. That's it. Not adding. Right, the next one. How do we move from B to 2B squared? We multiply it by 2B. Because B times 2B is 2B squared. Not so? So we must multiply 4 also by 2B. Not so? Therefore x is equal to 4 times 2b, which is 8b. You guys okay with that? There's one sum before you guys leave. We are told to arrange in ascending order. What does ascending mean? Smallest to biggest. If the question was to arrange in descending order, then what would I have done? Biggest to smallest. Okay. It's on page 61. So arrange in ascending order. Ascending means smallest to biggest. So how do I know which one is the smallest? So we can guess. Or what we do is we make all the denominators the same. So what is the LCM here for your denominator? 24. Can you see? 12 goes into 24, 24 goes into 24, 8 goes into 24, and 2 goes into 24. Which makes 24 the LCM. Okay. So 12 times what is 24? 2. So we times 5 by 2, which is 10. 24 times what is 24? 1. 11 times 1 is 11. 8 times what is 24? 3. 3 times 3 is 9. 2 times what is 24? 12. 1 times 12 is? So again, ascending is from smallest to biggest. So since all the denominators are the same, I look for the smaller numerator. Not so? So therefore, that is your smallest numerator, which makes 3 over 8 the smallest number, the smallest fraction. So we don't write 9 over 24 here. We write it in the format that is given. You guys understand? Then 10 over 24, which is 5 over 12. And then 11 over 24, which is 11 over 24. The last one is, do you guys understand? Right, for homework. For homework, I want you guys to do exercise 1 on page 62. Exercise 1 on page 62. That's homework for tomorrow. People enjoy the rest of your day? Only do number 1 and 2. Okay. Salam boss, how's it? Yes?
Rational numbers, would they be like adding and subtracting or just multiplying?
To get the equivalent fractions, only multiplying and dividing.